that this is kind of the minimum viable product of what a vertiport experience might look like for a passenger. So we said we want to unveil the aircraft, we want to show everybody what we've been working on for the last 4 years. The idea was, let's bring in all the components so they can actually see what that is. And it's actually very nice because we're in a parking lot. We're taking up 100 parking spaces and giving that back to the people in the form of interconnected mobility through various transportations. You've got buses outside, you've got the Tesla Loop, and now you also have urban air mobility. Now, this also takes it off of it being PowerPoints and allows people to come in and physically see and feel and touch what this industry might look like. So the first thing that we did was we wanted to kind of replicate this passenger experience. Now, in order for this trip to be a part of your daily life, it has to be a seamless integration and easily processed into the aircraft. Not like kind of a current airport today where you got to get a lot of security and it's going to take a while. So the idea was, let's just be able to show people that you're going to be able to show up, tap, check in, check your routes, answer any questions you have, get some information. It's your standard information board you might see at an airport. What we did here was we wanted to show all the work that we've done to understand consumers and how this might fit into their life. So we did a lot of data analytics, looking at how people move in and around a city to understand that typically we can offer a 25 to 40 mile range and we can cover a significant portion of people's daily commute. Now, if we look here, we go into the screen, we can look at there we go. We can look at a couple of case studies that show what kind of time savings you might be able to achieve. So if we say you're going to start at LAX, which means, I took a cross-country airline flight, I landed at LAX. There we go. And we're going to go from LAX to downtown Los Angeles. There we go. Now, in a peak hour, that trip could take you 2 hours. And it's only 20 miles. Through our aircraft, we think we could do that in about 40 minutes. Now that 40 minutes includes processing the passengers, getting them on board, loading and unloading the aircraft. The actual trip time is only about 12 minutes in that entire simulation there. And you get to avoid 2 hours of traffic. Giving people back that time and allowing them to go do that for work or spending time with family or just relaxing is such a great benefit that makes this whole project worth it. So this is the SA2. Now, back in 2020 at CES, we unveiled SA1. SA1 was the original concept aircraft, and now 4 years later, here we are with many more engineers on board and a lot of optimization to come up with this new design. Now, if you look at the two previous designs back to back, you'll notice that one of the biggest differences, we have no static lift rotors. All of our rotors tilt and they all provide value in every phase of flight. So during takeoff, the rear 4 rotors will tilt down and the front rotors will tilt up. The ones pointing down push the aircraft up and the ones pointing up will pull the aircraft along with it. As we start to transition into horizontal flight, they'll all transition to where they're locking and along the axis of travel and allowed to operate more like an aircraft in that configuration. It's much more efficient, so we're not carrying any extra weight during any phase of flight that's not going to be beneficial to the actual operation of the aircraft. It'll go 120 miles per hour and it'll operate about 1,500 feet. One of the most important aspects of this is going to be quiet. So during takeoff, it'll only be 75 decibels. It's like road noise. And during horizontal flight, it'll only be 45 decibels. So maybe just as loud as a modern dishwasher. It's barely perceptible. Some of the other things you should notice, it's a 4-passenger aircraft with 1 pilot. It's also designed to be reconfigurable. We could do 2 larger passenger seats, or we could also configure it for cargo with tie down. One thing you'll notice about this is, so during takeoff, the rotors in the rear will tilt down. And we actually purposely designed the hinges this way to block the passenger flow from being able to walk back there towards where the rotors would be. And it keeps them safe and away from everything. Now in flight, before the flight, they won't be spinning, they'll just be there, but you always just want to keep passengers away from something. You don't want them to bump their head or get it in the way or even put some FOD on the ground. You can see we have a dual side stick configuration. To control the aircraft, and we won't have any rudder pedals. It'll all be done through the controls themselves. We are trying to make sure that as we design the aircraft and the controls that it's going to be as intelligent as possible and try to make it as seamless of a flying experience. One of the key aspects of designing any aircraft like this is always safety. So we ensure that we're designing it to the FAA commercial aircraft standards. So it'll be redundant and fault tolerant to 10 to the minus ninth. So that means you could have one fault in every billion flight hours, and no single fault should ever take the aircraft down. We'll also be building in a lot of the considerations that EASA has put in as well. So we want to make sure that we've built the aircraft to the highest possible safety standards. It makes it a little bit more complex, but it's providing a better value to the customer because of that extra safety that's being built into it. Here and showcase some of the partners that we're working with to allow our aircraft to integrate seamlessly into the environment and into the national airspace and allow it to operate seamlessly. So center one on top, that's going to be the unmanned traffic, or the UAM traffic management system. You can actually see this as recorded data, so the little black aircraft you're seeing, that's actually live ADS-B data that they recorded and are replaying here today for us in the LA area. We have a partnership with Viasat to explore using SATCOMs to ensure we have a failover if we ever lose connectivity to any of our ground connections. You're actually seeing with their partner Airborne RF, they're showing what exact cell towers the aircraft would be connected to and where you might experience a risk of losing connectivity. So that blue shaded area, that's where they've actually determined there might be a problem having connectivity in that area, and we would probably switch over to SATCOM for that period. Down here on the bottom left, we're working with our partner Anro Technologies to explore how do you operate a vertiport. So they have this vertiport management system that allows us to do scheduling and reservations and system checks and telemetry and surveillance for the actual vertiport itself. You can see some of our simulation work we've done here is our in-house built simulation tools, so that way by the time any passengers ever got on board the aircraft, we've run the same route millions and millions of times in simulation. And then finally, again, with OneSky and our partner Echodyne, we're looking at, in best case scenario, we always have cooperative aircraft around us. They're broadcasting their conspicuity signals with ADS-B so they can tell us where they're at. This is great timing because now it's gone to the full screen. But in the scenario where you have somebody who's flying a drone and they've busted their requirements, so they're above their 400 feet and they start getting close to where we're operating, or somebody in a legacy aircraft that doesn't have ADS-B equipped, we can still see them through uncooperative measures. We can have our radar systems deployed and track those, and then feed that back into the system and update everybody in the system and say, hey, there's an uncooperative aircraft in this area, or you've got emergency services. Let's put a quick quarantine around that one spot, and then tell everybody to just avoid flying in this area for a minute. And we can do that all in